Okay, so now let's look at this example for the interrupt programming. Okay, the first example here, you are asked to design a decoration lightning system with 8 LEDs. Alright, so I have 8 LEDs for a client. The system will be placed on the front desk on the client shop to address customer to their shop. The placement of the LED is in a row. The client also requires to have two different set of sequential which have been defined in table Q51. Okay, so this is the pattern that the customer asked for, which is pattern one. You see here, this is the blinking from on off with 100 millisecond of delay for each of this blinking sequence. While the pattern 2, you see here, this is some sort of a running light started with two LEDs from the right and then it's running to the left with the delay between the blinking is also 100 milliseconds. Alright, so another information from this question is the system use a microcontroller AVR Mega 32 with 8 LEDs. Again, it highlighted the 8 LEDs as an output. They are connected to port C. So you know that LED connected to port C. Okay, LED sambung kepada port C. And since LED connected to port C, so port C must be output. Right, and two external interrupt. Alright, and that's okay. I forgot. Use timer 0 to generate the delay of 100 milliseconds. Okay, timer 0 to generate 100 milliseconds. So this one here, to generate a 100 millisecond delay, you need to use a timer 0. Timer 0 to generate 100 millisecond delay. Alright, next, what else? Triggering INT0 will generate one pass of pattern 1. So INT0 will generate this pattern 1, while INT2 will generate, INT1 will generate one pass of pattern 2. So here you know, INT1. So here you know that you have two external hardware interrupt, which is INT0 and INT1. Alright, the CPU frequency is 1 megahertz. Okay, so based on this information, you required to write down the C programs. So how to do that? Alright, first thing first, what you're going to do is you need to draw the circuits lah. Okay, before we do all anything, we draw our circuits here, the micropic circuits. Alright, so this is our micropic circuit and this is your port C. Okay, port C are connected, okay, to your LEDs, which is this is 8 bit lah. Okay, I don't want to draw 8 LEDs, so this is a 8 bits LEDs connected to port C, while INT0, INT1 connected to your switch. Alright, so now you are using INT0 and INT1. So you know that, recall back, the INT0 and INT1 are located at PD2 and PD3 respectively. Alright, so this is located at PD2 and the location of INT1 is at PD3. Alright, so you draw here PD2 and PD3, so sambung pada connect to your INT0 and T1. So what you're going to do now? Okay, so you're going to write your program. Okay, so in the previous class, in the previous video, you already learned how to write a interrupt program. So first step that you need in order to write your interrupt program is, okay, step number 1. What is step number 1? You need to include all the header file. Okay, so hashtag include, okay, avr slash io dot h. Okay, so this is the main header that you need to include. The second one here, you need to include interrupt header file. So include avr slash interrupt dot h. This is your step number one. Include the interrupt header file as well as any other header files that you are required in your programs. Okay, before we do the next programs, okay, so since this one here, okay, you see here the delay here that you need to generate is 100 millisecond by using a timer 0. So let assume lah, okay, because we still not yet learn how to do a time delay programming. So let's assume that the subroutine to generate 100 millisecond delay is already been provided. All right, so let's assume the subroutine here for to generate 100 millisecond delay is name delay 100 milliseconds. Okay, so you just use this subroutine here to call your delay. Okay, so we continue back with our program here. So this is the show step number one. And step number two, what is your step number two? Okay, you need to initialize the interrupt input output port as well as other input output ports. Okay, so this is step number two. Right, in order to do the step number two, okay, you need to make sure that you do it in your main program. int main void, okay, open curly bracket and you put close curly bracket down here. Okay, so step number two, what is step number two? Initialize your interrupt input output port as well as your other input output port. So in this case here, since LED connected to port C, so we initialize our port C sebagai output. So DDRC equal to OX F. Okay, so you know that it is port C equal to output port. Okay, next, what about here? Okay, since this is INT0 and INT1 is your external hardware interrupt, so you need to connect this INT0 and INT1 with your switches. So when this one here connect to your switches, what happens is your PD2 and PD3 should be your input port. So we just initialize all the port D as a input port. So DDRD sama dengan kosong. So all the port D equal to input. Okay, next, what are you going to do? Okay, before we start with our others programming, alright, so since this one here is your port D is connected to your switch, so make sure that you enable your pull up resistor. So this port D equal to OX FF, okay, to enable the pull up resistor. Alright, next, what you're going to do? Okay, so this is step number two. Step number three, you need to enable your interrupt register. Okay, so how to enable your interrupt register? So to enable your interrupt register, you need to enable at your GICR. So what value that you need to put here in GICR? Since this one here, you are going to use the INT0 and INT1. So recall back, this is your GICR. Okay, so GICR consists of 8 bit. Okay, so you only need to focus on the last 3 bits here. Okay, the first 3 bits from bit 7, 6 and 5. Okay, so this one here, this is INT1. This one is INT0 and this is INT2. So what is the value that we need to put here? So since we are going to use the INT0 and INT1, so the value that you need to put here is 1, 1, 0, the rest you put 0. So 0, B, 1, 1, 0, 0, 0, 0, 0, 0. So INT1 and INT0. Okay, next. What else? Okay, after you initialize your GICR, you need to initialize your SEI lah. Okay, so SEI, right? Then after that, what are we going to do? Okay, we need to make sure that this interrupt only activate when you either falling edge or rising edge. Okay, so in this case here, we need to enable it at our MCU CR. What is the value here? 0B 00 00 10 10 10. So in this case, I use the falling edge trigger. Okay, every time I switch, it's falling edge from high to low. So what happens is dia akan trigger the interrupt service routine. Okay, so recall back, this is your MCU CR, also 8-bit size. Okay, so you need to focus on this 4-bit here. Okay, so this is for INT1 and this another 2 for INT0. So we put 10 10 as a falling edge. If you put 1111, what happens is a rising edge, etc. Okay, and then what else? Okay, this is step number 3. Step number 4, you write down your main program lah. Okay, so Y1, open curly bracket and close curly bracket inside. Do you have any program inside of your Y1 here? Okay, means that is there any LED lights up or any switch turn on when you while waiting for the interrupt to be invoked? No, so you just put blank here. So this is your main program. Okay, so this part. Then step number 5. Okay, what is the step number 5? The step number 5 here is, okay, so since now you are using the ISR, so step number 5 is you need to create your ISR, which is interrupt service routine. Okay, make sure that the ISR is, the name of your ISR is correct lah, according to ISR vector table. Right, so in this case here, we're going to use INT0 and INT1. So let's put the ISR, okay, for INT0 underscore vec. Okay, we do the INT0 first. Okay, open curly bracket and close curly bracket. So what are what we call here, the program that you need to put here inside of your ISR. Okay, so since when the INT0 is invoked or is activated, what happens is the pattern 1 will be displayed to your LED. So since this is the sequence here, okay, the red color here is where your LED on, while this one is LED off. Okay, the first sequence here, what happens is all the LED are turned on. So why not we put, okay, since our LED here connected to port C, okay, so this is LED all connected to port C, so you put port C. Okay, what value do you need to send out to your LED so that your LED will, all the LED will turn on? So you put 0B. Since this one here, what type of command we use here? This one we use a command cated. So for command cated, you see here this lukisan here. Okay, all the cated or negative terminal are connected to ground. So in order to make this LED turn on, you need to send 1. If you put 0, the LED will off. Okay, so since this one, all the LEDs should be one, so what happen is you need to put 1 1 1 1. Okay, I always like to do in binary number because it easy for me to see the pattern lah. Okay, so this is all the LEDs light up, so I put 1 1 1 1 1 1 1. So this is all the LED lights up, and then after that I call the delay 100 millisecond delay. So in this case here, I call this subroutine that already provided in order to generate 100 millisecond delay. Okay, once we learn about how to generate a delay, so then after that we'll see the programming inside of this subroutine named delay 100 milliseconds. So we just put delay 100 millisecond, just call that delay 100 millisecond. Next, the second sequence, what are the second sequence? All the LED turn off. So just write down port C equal to kosong. So all the kosong here will go to your port C. So automatically your LED, all the LED will turn off. So then you call your delay again. Milliseconds. And this is for the ISR. For INT 0. Okay, next we are going to do the ISR for INT1. So again, you put an ISR. Okay, make sure that the name is correct. INT1 underscore back, open curly bracket and close curly bracket. Okay, so whenever you press the INT1, whatever is the pattern 2 will be displayed to your LEDs. So this is the pattern 2. Okay, the first one, the first sequence here, what happen is 2 LED from bit 0 and bit 1 is turned on, while the rest turn off. The second sequence, bit 3 and bit 2 turn on, the rest turn off, and until the fourth sequence, 7 and 6 only turn on, the rest will turn off. So how to do that? Okay, simple. Just write the simple programming. No need to use, of course lah, this one here. Okay, you can use the for loop. Okay, for loop with a left shifting, but I don't want to do that because it's very confusing. Okay, I just want to write down the simple programming. Alright, so here, what is the first sequence that you need to send out? Okay, port C sama dengan 0B. Okay, LED 7, 6, 5, 4, 3 and 2 is turn off. 0, 0, 0, 0, 0, 0, while LED 0 and 1 turn on. Just simple as that. And then call your delay. Okay, make sure that delay name is similar lah, sama dengan this one. Okay, because it's 100 millisecond delay. Okay, next, port C. What is my second sequence? Okay, so 0B. This one off, 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 while this one is on and this one also off. Okay, that's why I always love to write in binary, because I can what we call here, I can compare the patterns here. Okay, I can see the pattern clearly within my binary value and with this pattern here. Okay, then we call a delay 100 milliseconds. Okay, then sequence number C, the third sequence is 0 bit. This one padam, then turn on. The rest is padam. Okay, call a delay. And last but not least, your sequence 4. Okay, so port C. Okay, so bit 7 and 6 turn on, the rest padam. And this is a delay, call a delay 100 milliseconds. Just like that. So we finish this program here. Okay, the pattern that the customer needed to put to the client needed in order to put in the shops. Okay, next we look at the second punya question, example or question. Okay, assume that the INT0 and INT1 pins are connected to switches named S2 and S1. Okay, so first, what you're going to do is you need to take all the information inside of this question here. Alright, so you know that T0 connected to S2, INT1 connected to S1. Okay, write a program which whenever S1 goes slow, okay, means that whenever you press your S1, okay, when your S1 is pressed, okay, so this one here, I put here, S1 is pressed, what happen is, port C, the content of port C is increases by 1. So port C sama dengan port C plus 1. Okay, you increment the content inside of your port C. And when S2 goes slow, okay, when you press your S2, which is the content of port C will decreases by 1. So this is port C sama dengan port C minus 1. Okay, and when the value of port C is same or higher than, okay, when port C is greater or higher than 64, apa yang berlaku? What happen is PD1 akan jadi high. Okay, otherwise it is low. Show in your program, you are required to write the full program using the C language that implement the operating system. The program should include these things here. Okay, first, declaration of variable header, files to be included, declaration of interrupt vector, initialize of pawn and pin access in the program, write the code that implements the INT to ISR, initialize of your relevant interrupt used in the program, as well as the code or relevant interrupt service. Okay, so now what you're going to do is, okay, we draw our circuits here. Okay, so this is our circuits. Okay, we have a port C. Okay, the value of port C will increase by 1. So this one here, port C, you need to make it as a output port. Why? Because you send out the value to port C. Either it increase by 1 or decrease by 1. So port C as a output port. What about INT0? Where is the location of INT0? This is at PD2 and this is at PD3. Okay, you need to remember lah this one. Okay, INT0 always at PD2, INT1 at PD3, while INT2, okay, INT2 at PB2, port B pin number 2. Right, so you have the PD. Okay, so this is PD2 and PD3. So this is connected to your INT1, INT0. Okay, next you have another input. Okay, another one here which is a PDI. Alright, which is whenever the port C greater than 64, the PD will become high. If less than 64, the PD1 become low. So this is of your PD1. So PD1 here, you need to make it as an input or output. Okay, since you send the value either high or low depending on the port C punya value, so the PD1 should be your output port, become your output port. Okay, so you already locate your circuits here. Okay, and then you identify which one become input, which one become output. So this one you know lah, because the INT0 and INT1 is an external hardware interrupt, so you know that is your input ports. So we just proceed with our programming. Okay, just write down the programming. Okay, first it asks you to declare all the relevant header files to be included. Okay, so macam biasa, our first step, what is our first step? Okay, include the interrupt header as well as other necessary header. So include avr slash io dot hash and include avr slash interrupt dot hash. Okay, this is your first step. Okay, next, declaration of your interrupt vector. Right, this is your interrupt vector, your interrupt service routine, your interrupt vector int0, int1. So this one here, we just, okay, if I have this kind of question, I always write down the whole program instead of write one by one according to this question. Okay, I advise you to write down the whole program and then later I will mark according to this marks distribution here lah. Okay, so next, step number 2. What is our step number 2? Okay, step number 2, you need to initialize the interrupt input output port as well as the other input output port. So in this case here, okay, we started with int lah, of course lah, int main void. Okay, so open curly bracket and then you put a close curly bracket down here. Okay, so step number 2. What is step number 2? Okay, since this PD1, okay, since this port D here is a combination between the output and input, so you can do that D R D sama dengan 0B. Okay, you make all the other output, all the other pin as an output, while only PD2 and PD3 as a input. Okay, so how to make as output? You put 1 lah, 1 1 1 1. Bit 3 you put 0. Okay, bit 3 put 0. This one also 0 because it is PD2 and PD1 tak 1, PD0 also tak 1. So this is, you know that this is int1 and int0. So PD2 and PD3, PD3 as input. The rest you make it as a output. And then enable your pull up resistor. So how to that? You just put port B sama dengan 0B. Okay, all the output here that you initialized earlier, you give a 0, while the input you put 1. So this is how you enable the pull up resistor. Okay, next, any other input output port that you need to initialize? Yes, you have the port C kat situ. Port C you need to initialize as the output port. So DDRC equal to OXF. Okay, so that is your second step. Okay, what is your third step? Enable all the interrupt register. Okay, since this one here, how to enable the interrupt register? GICR. What is the value that you need to put out? Okay, 1 1 0 0 0 0 0 0. So you know that you are using int0 and int1. Next, okay, you can follow by, okay, before we enable the interrupt globally by using the SEI, we can enable our interrupt trigger, either is level trigger or edge trigger. So in this case, I using the edge trigger, MUCR. Okay, previously we were using the falling edge. Now I'm going to use the rising edge. So I just put 0B 0 0 0 0 1 1 1. Okay, so rising edge for both int0 and int1, then followed by SEI. Okay, next, your main program. Okay, while you're waiting for interrupt to be invoked. Okay, so why one? So what you are going to write inside of this one? Anything that you need to write down inside of your while one here? Nothing. Okay, so you just let it blank. Okay, so you just waiting for the INT0 and INT1 to be invoked. Okay, so now you finish this part here. So maybe because not enough space, so maybe I can segregate something like this. Okay, now we continue, right? Sambung ke atas. Continue with, okay, this is step number 4. Step number 5, your interrupt service routine. Okay, so now you have two interrupt here, so you have two ISR that you need to create. Alright, so the first ISR is ISR INT0 underscore vec. Make sure that the name is correct. Okay, so open curly bracket and close curly bracket down here. So under ISR0, what are you going to do? Okay, you see here, whenever you press the INT0, which is a switch to, port C will be decremented by 1. So you just put port C sama dengan port C minus 1. As simple as that. Okay. Next, what are you going to do? Okay, you have here. If the port C greater than 64, okay, you need to use the if else statement. Okay. If port C, okay, is greater and equal than 64, what happen? Okay, so open curly bracket. What happen if the port C greater or equal 64? You see here, PD1 equal to high. Okay, so you just put here port D equal to port D, okay, or with 0B 0000010. Why I write something? Why I write this this kind of lines here, this kind of program here? Because I don't want my port D, the value of it, the initial value of port D will change. Okay, I don't want to change any value of any bit of the port D except bit number 1, which is your PD1. I only want to change my PD1 only. The rest I want to follow the previous value. Okay, contoh lah. Okay, we put a contoh here. Okay, let's say lah, this is the current value of my port D. Okay, port D. Let's say that the current value of my port D is something like this. Okay, now I just want to change this here daripada kosong so that it become 1. So what happen is I OR-kan with this value. Okay, 10 10 00 0001 or with 0 0 0 0 0 0 1 0. So what happen here is this become 1. This is 1 0 0 0 1 0 1. See, only this one is changed, while the rest of the bit, the value is remains. So that's why I use the port D sama dengan port D or with 0B 0 0 0 0 1 0. Okay, because I want to make my port D 1 high. The rest of the bit are remains. Okay, follow the previous value. This is what happen when the port C greater than 64 lah. Else, what happen kalau dia smaller than 64? Okay, else port D equal to port D and with 0B 1111 11 0 1. Okay, kenapa pula letak N situ? Why I need to use the N, not or similar to this one here? Okay, let's check here. Okay, this is our port D. Okay, let's say lah, this is the port D. This is the current value of port D. Okay, 10100010. Now I want to change this one here from 1 to 0. So what happen is 10100011. I end with this number here. 11 sorry. Okay, 111110. So what happen? 1 and with 1 you get 1. This is 0. This is 1 1. Oh sorry, 0 0, because 0 and with 1 you get 0. This is a 0. This is 1 0 and 1. You see, only this bit changed. Okay, this bit value is changed. Others bit follow the previous value. Yes, so that's why I use the AND instead of OR. Alright. Then what I'm going to do? Okay, I just put a close curly bracket. So this is my INT0 interrupt service routine. Okay, next I need to do the ISR1. ISR for INT1 service routine, interrupt service routine. Okay, just put something like that. Open curly bracket, close curly bracket. So when INT1 is pressed, what happen is port C sama dengan port C plus 1. Just write down port C sama dengan port C plus 1. And lepas you increase the port C, what happen is you need to check lah whether the port C is greater than 64 or not. Okay, so you use that if port C greater or equal than 64. If yes, what happen? Just copy back this line here. Okay, port T sama dengan port D or with 0B 00000010. Okay, else if the port C less than 64, what happen is, okay, port D equal to port D and with 0B, alright, 1111110. Close to that. Just like that. Okay. So next, okay, let's check. Okay, the thing that needed in here in this question here. Okay, I put another color lah. Yellow color. Okay, declare the relevant header files to be included. So you already declare the relevant file to be included. Okay, declaration of interrupt vectors. Okay, you have already, this is your interrupt vector that you're going to use. Okay, initialization of the port and pin access in the program. Okay, this is the initialization of the port and the pin access in the program. And then write the code that implement the INT2 ISR. So not INT2, this one here, this is INT0 ISR because we only using the INT0 and INT1. So you already implement this ISR for INT0. Initialization of any relevant interrupt used in the program. So you initialize all the interrupt that used in the program, which is INT1 and INT0, as well as the MCUCR. So this one you already initialized. And code for all the relevant interrupt service routine. So this one, another interrupt service routine that you need to do, just like that. Okay, so that's all. Thank you. Okay, so that's all for our interrupt programming. Okay, so in the next video we will see how to program in the board